Welcome back. We were discussing about transport layer in general, right? Now we will move on to specific protocols in transport layer of internet. So internet is having two different protocols in the transport layer. One is connectionless protocol, that is UDP, and the second one is connection oriented, that is TCP. So we will see UDP in this session and the TCP in the next few sessions. And these two protocols, if we compare this UDP and TCP, they complement each other. That is, the connectionless protocol can be used in some situations, whereas connection oriented one can be used in some other application. So depending on the nature of application, the corresponding protocol can be chosen. And if we look into UDP, it does almost nothing beyond just sending packets between applications. So in that case, it is the duty of applications to build their own protocols on top of these UDP to provide other connection, reliability, etc. Whereas in case of TCP, it does almost everything. That is, it makes connections and adds reliability with retransmissions, flow control, congestion control. Everything will be provided by the TCP itself on behalf of the application that use it. Okay. As an overview, UDP is a very simple protocol and it has some very important uses such as client-server interaction, multimedia. Such cases we can use this UDP. Whereas most of the application in internet need some reliable sequence delivery, right? In such cases, we cannot use this UDP. There we are using this TCP. So we can call this TCP as the main workforce of the internet. But in some cases, UDP will be enough. Such case we can use this UDP. So outline of this session and the forthcoming sessions are, we will focus on this UDP, then transmission control protocol, in which overview of the TCP will be the segment header, connection establishment and release, connection management modeling, and TCP congestion control. These are the different topics to be covered under this transport layer of internet. Now coming to user datagram protocol or UDP, Internet Protocol Suite supports a connectionless transport protocol, that is UDP, and it provides a way for applications to send these IP datagrams without having to establish a connection. That is the main specialty. There is no need of establishing a prior connection. Whatever paths are available through the network, these IP datagrams can be forwarded. So definitely this UDP service will be fast because there is no need to wait for establishing a connection and all. It can be provided, it can be forwarded through any routes available. The thing is that there is no reliability. Some packets may be lost and all. That things will not be addressed by this UDP. So in such applications, whereas error control or reliability is not much concerned, but fast transmission is the most important requirement. In such cases, we can use this UDP. And this UDP transmits segments. So in case of transport layer, the data fragment or data unit is actually called segment. And UDP transmits segments consisting of an 8-byte header followed by the payload. So header part is 8-byte. We will see the format of this UDP segment. So UDP header is like this. It contains very limited information. The source port number, the destination port number, UDP length, UDP checksum. These are the 4 different items present in this UDP header. The 2 ports serve to identify the endpoints within the source and destination machine. Source ports identify the source machine endpoint, the transport endpoint, whereas the destination port indicates the destination machine endpoint. And when a UDP packet arrives, its payload is handed to the process attached to the destination port. So the payload part is the actual data part. This is the header part, right? That payload part will be handed over to the corresponding destination transport entity. So you may think that why this extra information is required. IP datagram is enough from source to destination, right? But that is not the case because the communication, the actual communication is from a process and the sending machine to the process at a destination machine. Not just between 2 different machines, but between two different processes within two different machines, right? So how to identify these processes, the sending process and the receiving process? For that, these port numbers are used. The main value of UDP over just using raw IP is the addition of source and destination port numbers. Without these port numbers, the transport layer would not know what to do with each incoming packet, where to hand over it inside the transport layer, to which process it should be handed over. That information will be there only in the header of this UDP packet. Using port fields, it delivers to the embedded segment to the correct application. The source port is primarily needed when a reply must send back to the source. So we know that destination port is definitely required, right? Because it addresses or specifies to which application process this segment should be provided. Now what about the sending port number, sender's port number? Yeah, that is required if an acknowledgement or if a reply is to be sent back to the sender machine. In that case, we need this sending port number also. It can be taken as a destination port for the reply message. By copying the source port field from the incoming segment into the destination port field of the outgoing segment, the process sending the reply can specify which process on the sending machine to get it. So if you have to provide a reply back from the receiver to the sender, what it will do? Yeah, from the received packet, it will take the sender's port number, and that port number will be put as a destination port number for the reply back. So we have seen two different fields of this UDP header. Those are sender's port number and destination port number. And the third field was UDP length field, right? Which includes the 8-byte header and the data. Totally how many bytes are there together in this header plus data in this UDP segment. That length will be there in the length field. And the minimum length is 8 bytes to cover the header only. If there is no data part, only the header will be there. So minimum length is 8 bytes. The maximum length, there is a restriction for the maximum length also. That is, it should be maximum 65515 bytes. So that is, it should be lower than the largest number that can fit into 16 bits, because the size limit on the IP packets. So IP datagram, or in the network there is a restriction, that is for an IP datagram this should be the maximum payload field. So actually the payload or the data part of an IP datagram is a UDP segment, right? Yeah, with the UDP segment, an extra header from the network layer, that is the actually IP datagram. So the data part of the IP datagram is the UDP segment. So there should be a restriction, there is a restriction imposed by this network that this should be the maximum payload that can fit into a particular datagram. So based on that, the maximum length of a UDP segment is fixed as this much. And the fourth field is checksum field, that is optional actually. Anyway, if it is used, it is used for providing extra reliability. And how the checksum will be computed is like this. For computing the checksum, the UDP header field, that is these four fields will be taken. So in that UDP checksum is not yet computed, right? So this field will be filled with 0 initially. So all these together, and the data part of this UDP segment. Data part of a UDP segment is actually the data came from the application layer, right? That is the payload field of this UDP segment. Yeah, that part plus an IP pseudo header, that also will be taken into consideration. IP pseudo header, we will see what's the content of IP pseudo header. So this IP pseudo header, the data part of this UDP segment, and this header part in which this field is filled with 0, all these together will be taken for computing the checksum. And these will be divided into 16-bit units. Okay, all this data will be divided into 16-bit units. So definitely the total number of bytes should be even, then only we can group into 16-bit units, right? So if the number of bytes is odd, in that case one extra byte will be added, or one extra byte will be padded into this data unit, that with all zeros. In that extra padded byte, all the bits will be 0 to make it just an even number. And thus, how to compute the checksum is after dividing in or after grouping into 16-bit data units, all these will be added up together in one's complement, and the result also, the one's complement of the result will be taken. That is a checksum value, and that checksum value will be inserted into this UDP checksum field, and that will be sent from the source machine. And with the destination machine, what it will do, again the checksum will be computed using the same procedure. Then here there is not 0, right? The checksum value will be here. So when we compute the checksum again at the destination, the result should be 0 if there is no error. Otherwise, it means that there is some error result. So depending on the checksum computed, if it is non-zero, that data or that transmission contains some error. Otherwise, it will be accepted. That is UDP checksum. Now let us see what is actually this IP pseudo header that will be taken for this UDP checksum. Pseudo header means the IP header itself, that is the source address of the source address means the IP address of the source machine, IP address of the destination machine. Then this 8 bits will be filled with 0. Then next is actually UDP protocol number, that is 17, and the UDP length, total length of the UDP segment, that also will be given here. This is a pseudo header actually. This also will be taken for computing the checksum. So it contains the 32-bit IP version 4 addresses of the source machine and destination machine, the protocol number for UDP, that is 17, and the byte count for the UDP segment. How many bytes are there in the entire UDP segment, which include the data part and header part. And including the pseudo header in the UDP checksum computation helps to detect misdelivered packets. So if there is some error in the source address or destination address also, it can be found out. It can be found out using this UDP checksum. But you can think of one thing, that is we think that there is a protocol hierarchy, right? That means UDP doesn't know actually what is the IP address and IP address of the sender machine or destination machine, like that. UDP knows only the port number, right? That is our assumption. But here the UDP use the IP addresses, the lower layer addresses, right? So that is actually a protocol violation, right? Anyway, that is used in for adding reliability in both the UDP and TCP. Now, what are the different things does not do by this UDP and does do by this UDP? First, what are the different things does not do by this UDP? It does not do flow control, congestion control, or retransmission upon receipt of a batch segment. All that is up to the end process, the application layer. It's the duty of this application layer to perform all these extra supplementary functions. And what are the different things done by this UDP? It is providing an interface to the IP protocol with the added features of demultiplexing multiple processes using the ports and optional end-to-end error detection. So first thing it will do is, definitely lot of communications will be there from different application process of one machine to different application process of some other machines, right? Yeah, but limited port numbers will be available. So using these port numbers, all these applications how to communicate. So multiplexing will be done. Multiple application will be mapped into single port, and from the single port it will be delivered to different multiple applications on the destination machine. All these types of multiplexing, that is multiplexing between processes and port numbers, that will be done by the at the sender side and receiver side. Demultiplexing also will be done by this UDP, and it acts as an interface between whom the application process and the network. That interface will be provided by this UDP. And in some case, if you are using this checksum, an end-to-end error detection also will be done by this UDP. And where this UDP is actually suitable, area where it is especially useful is the client-server situation. In that case, establishing a connection each time is a time-consuming process, right? Often client sends a short request to the server and expects a short reply back. So if either the request or the reply is lost, the client can just time out and try again without establishing a connection and all. Simply it can send a reply request again. Not only is this code simple, but fewer messages are required, one in each direction. than with a protocol requiring an initial setup like TCP. Instead of these UDP, if you are using TCP, lot of initial setup messages will be required for each time communication. Even if the actual data communication is very short messages, a request and a reply, for that a lot of other messages will be required for initial connection setup and connection release if you are using TCP. In such cases, we can use this UDP. And some other application, domain name systems. So domain name system, as you know, to resolve these names, we are given a URL that name. So the URL will be resolved to get the corresponding IP address using this DNS service, right? Yeah, a program that needs to look up the IP address of some host name. For example, if we are typing like this, cs.berkeley.edu, it can send a UDP packet containing the host name to a DNS server. So DNS server will keep a lookup table corresponding to each URL or host name. There's an IP address mapped in that lookup table. Using that, it will retrieve the corresponding IP address. So the server reply with UDP packet containing the host IP address. In such case, we can use this UDP instead of TCP. So if you are using this UDP, no setup is needed in advance and no release is needed afterward. Just 2 messages go over the network for this purpose. So these are all about UDP. In the next session, we will see the TCP in detail. Thank you.